I'm going to do a somewhat advanced hydraulics lesson on a 480 valve body, specifically the 1-2 shift. We're not going to get into much else, but mainly concerning something that, like, one of our customers brought up today on one of the groups. We've seen problems that started when the Holley terminators came out that we really, I'm not gonna say we'd never seen before. We had a couple of complaints, but it was an extremely rare complaint, and it was almost always something we could trace back to the tune with the tables, the way they were tuned, like in HP tuners. And we could usually educate the customer how to adjust the tune and correct the problem. And I'll get into the Holley aspect of it in a minute, but we're gonna go just straight on to the valve body. The 1-2 shift valve is the one that's closest to the manual valve. So you have the manual valve bore right here, and you have a 1-2 shift valve right here. And then the 2-3 shift valve, 3-4 shift valve. So they're in order across the valve body, basically in the order that the shift occurs. So the 1-2 shift valve, you have the inboard end that has no oil pressure on it until the transmission shifts to third gear. And the 2-3 shift valve gets upshifted using the solenoid, B solenoid, it upshifts, and basically the oil that upshifts the 2-3 shift valve also acts on the 1-2 shift valve to keep it in the upshifted to second gear position. And the reason for that is so that when the A solenoid comes back on for fourth gear, this valve can't stroke and return to first gear. Otherwise you would never have fourth gear. It would just, when it commanded fourth gear, it would go back to first. So there's a reason they put third gear oil here. Basically it's actually solenoid B oil, but the oil with the combination of the spring on this end can't be overcome by the same pressure of oil on this end acting on the valve to stroke it. So this little spring is pretty light on this valve, and you can't go much heavier. You can get really in depth. You can study where all the oil acts on this valve, the AFL oil and the solenoid B oil, which is based off AFL, and the spring pressure, and you'll figure out that we tried it, several different spring tensions, going heavier on the spring, basically for the reasons I'm going to discuss here, and learned that basically the stock spring is what you want to use, and you do not want to use a Sunac spring here because it's lighter and it's going the wrong direction for a performance application. You really need to keep the stock tension here, but unfortunately you can't go heavier. So the solenoid goes in, the bore on this end. This valve is exactly 1/2 inch diameter. The oil acts on it. You have AFL oil, which is line pressure reduced to approximately 95 to 105 psi, so it doesn't put as much strain on the solenoids. We know from experience these solenoids will take full line pressure, 230, 240 pounds, but it's regulated down to about 100 psi. It ends up going in this hole, what we call like filtered AFL oil goes in this hole to act on that valve between the solenoid and the first line of the valve to stroke the valve against the spring. It goes through this tiny hole right here, which is approximately 25 to 30 thousandths diameter hole. The old hack trick was to drill those holes bigger to make up for a leaky AFL circuit and lowered AFL pressure that could cause some quirky problems with the shift valves. It's a hack trick. I know some guys swear by it. You don't want to drill those holes any bigger. We're really specific. We played with that a lot too on some different stuff, some testing. We have a valve body test stand. We can test stuff that most people can't. This shift solenoid, if you bend these tabs and you take it apart and you measure the hole that is allowed to exhaust wide open, it's about 80 or 90 thousandths. So if you drill this hole bigger than about 30, 32 thousandths and you only have an 80 thousandths exhaust, you will actually get residual pressure on this end of the valve, and it can start to partially stroke against the spring and cause you to burn clutches, do all kinds of weird stuff. You have 100 psi that's constantly pouring in this hole through a little bitty orifice, and if you get more than 2 or 3 psi on this valve, it will begin to stroke it because that spring is pretty light. We learned years ago, it's actually a problem we had in the early days. We were using Transgo plates on some of our builds, just a brand new stock replacement plate, and they had a batch of plates that these feed holes were punched out to 60 thousandths, and they were actually partially stroking the actually it wasn't the feed holes. It wasn't the feed holes that were too big. there's a hole in the front of this plate, I want to say it's this one, that feeds oil into the overdrive circuit all the time when you're not in overdrive, and keeps it pre-charged so it doesn't have to bleed on the shift. And the hole was punched to 60 thousandths, and the bleed hole on that circuit is, I want to say it's this hole, just going off memory, that's about 93 thousandths. And that 93 thousandths hole can bleed a 30 thousandths hole at 200 psi. It cannot bleed a 60 thousandths. You'll actually get residual pressure in the overdrive circuit and burn the overdrive clutches. In a fixed line pressure unit, we were burning clutches in 1 mile. Called Trensgo, told them, hey, you got a problem. They figured it out and recalled the plates. And so that was probably 15 years ago that I solved that, and we learned a little lesson on that. But the same theory applies to the solenoid feed and bleeds. But this valve stroking to give 1-2, it strokes inboard to give you first gear. So when the solenoid turns on, A solenoid on is first gear, and then A solenoid off, B solenoid off is second gear. So this valve has to get kicked out towards the solenoid to shift, make an upshift from first to second. Like I said, there's no oil on this in first gear or second gear, so you only have the light spring kicking the valve. You have the solenoid, which is fast acting. We've also learned AC Delco solenoid quality is better than the copies. And so, there's been times where you could not get an AC Delco solenoid. They seem to be reasonably available these days, although much more expensive than they were 5 or 10 years ago. We've cut these apart, we've cut other solenoids apart. The orificing's pretty similar usually, but the AC Delco solenoid has smoother internals. So you have 80, 90 thousandths bleed on this. You're constantly putting oil in this hole. This solenoid it turns off. The oil spurts out through the exhausts, which is these areas, like, let's see if I can point it out here. Right there is the exhaust. So the oil comes out, exhaust, and the spring is the only thing pushing this valve out. And like I said, fairly light spring. So there is, if any shift is going to be slow on a 4L80, it's going to be the 1-2 upshift, just by the nature of the way this valve works. Fully manual, state-of-the-art billet valve body, turbo 400 power glide on an upshift with electronic or air-operated shifter, Holley Dominator, data logging it. You're talking 250 to 400 RPM typically on an upshift in a fairly fast car. We're talking 7-8 second cars. So you're going to have a lag of 250 to 400 RPM on aluminum drum transmission with the state-of-the-art valve body, everything perfect. If you actually data log it, that's what you're going to experience. So to expect this valve body that was not meant for anything that fast to shift in anything less than that, it would be unreasonable. To me, it's reasonable to expect it to take double that, but it really shouldn't. It usually doesn't. We're typically seeing anywhere from 300 to 600 RPM, even on 8-9 second combos. So that is with typically an iron drum, pretty basic 480, stage 3, stage 4, stage 5. Aluminum drum's not going to make a huge difference, but there are some differences we can make when we set this valve body up. So the guys that are like 1,000 plus horsepower, nowadays the D3 is all, we've gone to all the D3 Pro, but if you have an older plain D3, the D3 Plus and the D3 Pro will shift faster from first to second. Nothing happens really differently with this valve, but just the way the rest of the circuit works, there's less wasted oil going into second gear. Also, if you have an aluminum drum and you're not running an intermediate band and you don't have to activate the intermediate servo to apply that band, it's going to shift faster. Because again, there's less wasted oil making the 1-2 upshift. So that's kind of the quick down and dirty lesson of what we see there. And we've done a lot of experimentation and using the valve body test machine, the dyno, some pretty fast cars. I actually have a method to put some circuitry on here to put oil on into this valve. It's just something we haven't tried to finish up. We've got other projects that we're knee deep in, and just hasn't been a concern. The biggest issue we see is on Holley Terminator, because it does not differentiate in the software at wide open throttle between a 1-2 and a 2-3 shift. They don't shift timely. They don't allow for the probably 1/10 or slightly more than 1/10 of a second for this to not only exhaust, shift, exhaust the first gear oil, and to move the second gear oil up here to where it goes into second gear, to make it through the second gear circuit into the clutches and apply the clutches and execute a gear change at the planetaries output shaft. It takes time. All that takes time. Even after hydraulics are done, there's still mechanical happening. It takes a little bit of time to fill circuits. Intermediate clutch pack clearance has an effect. Low reverse servo clearance has an effect, depending on the hydraulics and how they're set up. You know, clutch pack type, as far as frictions, can have an effect, although we've kind of proven that you don't need like a waffled friction or everything. We just want to kind of make everybody aware that with the Holley system, the Terminator, that's been something we experienced. We started seeing it. It took us a little while to realize and relate it specifically to the Holley. So you get the guys that say, oh, you have to have a billet manual valve body to anything that makes power. Well, that's not true. We've been running basically a OEM valve body at 1800 plus wheel horsepower for over 15 years now. Well, I'm probably lying. I'm probably going to say 12 years. We came out with D1 in 2010, so we're talking 14 years at this point that we've had valve bodies that have worked at well over 14, 15, 1800 wheel horsepower automatic shifting that we really didn't have any serious issues with, and nobody was having to program in a huge amount of lead to make it shift with HP tuners. Just specifically with the Holley, we've seen way more lead having to be programmed in. And the cars have gotten faster. The average stuff's making more power now. So the D3 Plus, D3 Pro, by the way the circuits work, will shift faster on a 1-2. The other thing, I could get pretty deep into the hydraulics. You got a 1/2-inch shift valve here. If you have, if I remember right, these are 15 millimeter, the manual valve. So if you look at the way a valve moves in a valve body, you move a manual valve, if you're using a full manual valve body, like the Extreme Automatics, this valve moves and it cracks from one circuit to another like this. The bigger the diameter of the valve, the more immediate cracking pressure you have on a circuit to fill it faster. So the bigger the valve is, the better it works. But a 1/2-inch valve is pretty large. It moves a ton of fluid when it cracks and fills the circuit really fast. So there's not really a problem there. There's the billet full manual valve bodies work great. We sell a lot of them. We use quite a few here building transmissions. But Lonnie himself at Extreme Automatics does not want to build a transmission at above a certain horsepower level with an automatic shift valve body, because he doesn't have the relevant experience to do so. And honestly, to somewhat agree with him, it's a headache to try to teach people to tune their car to work with an automatic valve body, rather than just sell them a manual valve body and they don't have to mess with that. It simplifies everybody's life if they don't have to tune it. But with the technology we have these days, it's not really, you can have an automatic shift and quite a bit of power and it works fine. A lot of issues have been fluid pickup issues with fluid slosh in fast cars. We've tried over the years several different methods to improve or correct that, resolve that, and we've got the new fluid pickup tubes we make that use a Turbo 400 filter, and they've been working really well for us. So that seems to have helped a lot. Educating customers on dipsticks not being accurate, fluid level not being accurate, causing burnt clutches. You get past that, then you get past the fluid pickup issue, then you get past the tuning issues, and then usually we've had really good success at higher power levels. So, but it's been I've personally been educating other builders and consumers for well over a decade now to make this stuff work. And there's tons of supposed internet experts that they've got the recipe that makes it work, but they haven't really put in the homework that somebody like myself or Lonnie has, and figured out how to be successful. So that's probably the quickest version of that I can give. I'll try to answer any specific questions that somebody has and kind of expand on it if we want to have that discussion.